a very nice slide of the tongue. Alright? There we're looking at the slide of the tongue. Okay?
Iris identity.
And
On mine?
this is the tongue that we're looking at right here. Alright, so there's a lot of skeletal muscle. So this is a mastical motor skeletal muscle. That's the mucosa of the tongue right here. There's a lot of fat in there. And the tongue, as you know, has a very rich nerve innervation. So the tongue has a very rich nervous innervation, and it is also a very vascularized structure. So whenever I want to look for an artery, I always pick up the slide of the tongue, and it shouldn't disappoint you. So there, this seems to be the lingual artery. That's one of the major arteries, and there we can see a number of nerves going with the lingual artery right here, and we suspect this to be, for example, one or some of the terminal branches of the hypoglossal nerve, maybe traveling with the tongue. So these are a number of nerves right here in cross section. Okay, and there we can see smaller vessels, smaller arteries. Okay. Okay. So this is a nice example here of a muscular artery. This is a nerve right here, quite a nice nerve. So I suspect this would be the hypoglossal nerve traveling with the lingual artery right here. So that's a nerve right here in cross section. So these are nerves right here. Beautiful nerve right here, like some straws laying down. Alright. And then beside this is the artery. Okay? So this is a muscular artery. There's a tunica adventitia out here. That's the tunica media, and let's see if we see any internal elastic membrane. Alright. So there is an internal elastic membrane right here. Okay, very good. That's the internal elastic membrane that you see right here. Okay. And the endothelium is quite clear. Alright. And there does seem to be an external elastic membrane. Alright? An external elastic membrane is here. That's the external elastic membrane right about there. Alright? Right about here, skirting on the outer side of the tunica media. There is, in some cases, we can see a bit of the external elastic membrane. Not as prominent as the internal elastic membrane. So if we went into an exam now, you define this as a muscular artery. It's a muscular artery that we're looking at right here. Okay? And there's a smaller artery beside it. Okay, this is a vein right here. It's a vein right here with a little arteriole. A small little arteriole right over here. Okay, this is a smaller artery right here. Okay. Now, let me move into the kidney and see if we can see some capillaries. Alright? Now we may or may not find them. I don't know. We have to look and see. Okay, let me try this one here. A large kidney slide here. Many times in the exam, and then we look at sinusoids. We need to look at some sinusoids. Okay? Which we'll find in the liver, find sinusoidal spaces in the liver. Also we find them in the nasal cavity. So the slides of the nasal cavity we saw recently had a lot of sinusoids. So there we see now the kidney. Okay, right here, this is the cortex of the kidney with all the glomeruli. And the glomeruli are a rare example because they're not many times seen in the mammalian species, but in other species we get what is called a rete mirabilis. The rete mirabilis, that's another sort of type of sinusoid type space, and the glomerulus is an example, it is said, of a rete mirabilis. Alright, between two arterioles. Okay, so sometimes defined as a capillary plexus, but it's really a very specialized form of a capillary plexus. Now, we're looking right here now, so that's the cortex of the kidney, and from there, you know, from your basic biology, that is what's called a nephron, and the nephron sends down what I refer to as the descending, from the distal convoluted tubules, there's a descending and an ascending limb of the loop of Henle. And right down in here, maybe we will be looking and seeing if we can find any capillaries. Okay. Now, preservation has to be very, very good to see capillaries. So I've just taken up this slide. Don't know how good the preservation is right here, but we will see. Alright. So expecting this region here to encounter capillaries. Now, the rough dimension of thin segment of the loop of Henle is about 15 microns in cross section, whereas a capillary will be 8 microns in cross section. So the capillary is the smallest of the tubules that you see. So the smallest luminal structure that is occurring in here, that will be the capillary. Alright? The smallest tube we can find in here, that is the capillary. 8 microns in diameter, whereas the thin segments of the loop of Henle, which look very much like that, like this here would be a thin segment of the loop of Henle. This right here, that's a good example of a thin segment of the loop of Henle. I don't have to find capillaries. That's a loop of Henle. So we need to find something that is about half the diameter of that. That has, as you see, about 2 nuclei in its wall. So the thin segment of the loop of Henle will have around 2 nuclei in its wall. What we need is a structure that is half the diameter of this and only 1 nucleus in its wall. Alright? So we look around here. Now but many of these capillaries will be very collapsed. Okay? Many of the capillaries are going to be collapsed. I think I see some, but I don't want to. For example, this boy here, that seems to be a capillary right here. This little boy right here. This is his nucleus at the side, and it seems as if there is 1 red blood cell right in him right there. So that's a little RBC right in a capillary. Now we have somebody named here, she's very hot at her histology. Very hot. Her name, I don't know if you know her, is Miss, not Mrs., Miss K. Cousins. Are you aware of her? Very good. Alright. Okay, buddy, hot at her histology. That's okay, buddy? Okay. So we see what? There are a number of little tiny, tiny little fellows, and this is another example right over. Right here, there's another little capillary right here. All we can see is 1 nucleus in the wall of the capillary. Alright? The preservation in this slide, how much would I give the preservation in this slide if I were to rate it? No, not 0. I would give this about maybe 4 out of 10. So the preservation could be a lot better. But at least we're able to distinguish capillaries from loops of Henle. Now, give a chance. So the wall is formed purely by what? An endothelium. And outside of that endothelium, there are a couple of cells going to rest on a basement membrane. So even in the arteries, etc., all endotheliums rest on a basal lamina, sometimes called basement membrane. And there are big, thick books written on basement membrane and all the functions of the basement membrane. It is a very important layer. Okay? Now, outside of this basement membrane, we'll find a couple cells called pericytes, and then we will find also some fixed macrophages, and we will also see, if we stain it in silver, there is a very delicate reticular